Hi guys, this is Pulkit Jain from Bennett University. So today we are gonna learn about CRC, or its full form is Cyclic Redundancy Check. It is a topic of computer networks and it is used in error detection. So what is an error? We all know that with the help of internet we are connected to the whole world and we send data from our computer to some another computer all over the world. Now there can be some error in sending the data. So what is meant by the error? Suppose let's take a simple example. I send the data 101 from my computer to some another computer and the data gets changed in the middle into the path and it becomes 100. So now there is no use of such data, it's useless because the data has been changed. And what is the cause of this change? Why there is some error in the data? There can be many causes of such error. Suppose I am sending my data from my computer here in India to my cousin's computer in United States. So there is a long distance between India and United States, and because of this the data and because of this long distance there can be energy loss of the data, or there can also be attenuation of the data, and there can be some natural effects also, such as lightning. It can also change the data, or suppose there is a machine which makes sharp noise when it turns on, it can also change the data. So we can try to reduce the errors to the minimal degree, but we cannot eliminate the errors at all. So we need to find some techniques so that we can find that if there is an error in the data, and we can also correct that data. So CRC is a powerful technique for the detection of error in the data, and CRC is the most widely used error detection technique, and it is a practical technique which is used today to find the errors into the data. So now let's understand how to use the CRC for error detection into the data. Okay, so the Cyclic Redundancy Check, or CRC, it is based on binary division. So what is binary division? Binary division is the division of bits using a group of bits, and it is based on XOR operation. So I will show how to use the binary division. So let's suppose the data is 101, 0101, 010. This is the data that the sender has to send to the receiver. Now for error detection in this data, we use a polynomial, or it is also known as g of x. So this data is the dividend. If we use binary division, and this data is the dividend. So let me write here in the form of a dividend. So it is 101, 01, 01, 010. This is the dividend, and this polynomial, it is the divisor. Now from where this polynomial came? So the sender and the receiver both communicate with each other and they agree on a polynomial that they will use for error detection and correction. So this polynomial is used as a divisor for their future communication. And it is also known as g of x. So now we have to divide this dividend by the help of this polynomial, but it is the values of x and it is the bits. So how we will divide? So first of all we will convert it into bits. Okay, so how we will convert it into bits? We will use the coefficient. We will simply use the coefficients of these x. So like it is 1 into x to the power 4 plus 1 into x to the power 3 plus 0 into x to the power 2, because the x to the power 2 is not here, so its coefficient will be obviously 0, and 0 into x to the power 1 similarly plus 1. Okay, so we will take all the coefficients, so it will be 1, 1, 0, 0. This will be our divisor, so I can write it here 1, 1, 0, 0, 1. Now by using this pure data, we cannot check, it is type of we can say it is impossible for error detection or error correction based on this pure data. We will need some extra bits, or we can call them the redundant bits, that the receiver puts into this data and then send the whole data including the redundant bits to the receiver. So what is the redundant bits? So in this polynomial, the maximum degree of this polynomial is 4. So we will add 4 zeros to it. We will add 4 0 0 0 0. These are the 4 redundant bits that we will use for the checksum. Now what will happen? We will use the remainder and we will replace these 4 bits by the help of we will replace these 4 bits with the remainder, and then we will send this whole data to the receiver. So the total number of bits that you send is m plus r. This is the simple formula which is used to calculate the total number of bits which will be sent to the receiver. So m is the message, total number of bits in the message, and r is the redundant bits. So in this case, the total number of message bits are 10 and the redundant bits are 4. So the total number of bits will be 14. Okay. So now we start binary division of this dividend with the help of this divisor. So we will use the XOR operation. So first we will put this 1 1 0 0 1. Okay. So in the division we will always start with 1. The division will always start with 1, and we will use the XOR operation. XOR operation is very simple. In case of the similar bits like 1 1 or 0 0, we put 0, and in case of different bits we put 1. Okay, so the 1 1 similar bit 0 0 1 1 1 0 1 0 0 0 and 1 1 0. Okay, now we have nothing to do with the quotient. Okay, there is nothing use of the quotient. We will have to use the remainder. Okay. Now as I said, we will always use the leading bit as 1. So from 1 we have number of bits 1 2 3 4, and the number of bits in the divisor are 5. So how we will carry on the division? We will carry a bit from here to 0. Okay, so now we will start with this number. You always start with 1, and here is 1. So we do 1 1 0 0 1. Again we will perform the XOR operation. So it will be 0 0 0 0 1. Okay, so now the number of bits after 1 is 0. There are no bits, so we will carry the 4 bits from up. 1 0 1 0. Okay, now we will perform the XOR operation. Okay, so it will be 1 1 0 0 1, and it will be 0 0 0 1 1. Now there are 2 bits, so we will carry on 3 bits. 0 0 0. From the XOR operation 1 1 0 0. It will be 0 0 0 0 1, and there is one single bit, so we carry the last bit here. Now after this one there is only one bit, so the total number of bits is 2. So now the division has been completed, and we will use this remainder in place of these 4 zeros, in place of the redundant bits. But we can say in the remainder there are 1 2 3 4 5 6 bits, and there are only 4 bits. So how we will replace these 4 bits with these 6 bits? So the simple trick here is we will use the last 4 bits. So we will use these last 4 bits to replace the redundant bits. So we will not start from the MSB, we will start from the LSB. So now these bits will become 0 0 1 0. So this will be, okay, I can write it here. So this 0 0 1 0, this will be the whole data that the sender will send to the receiver. And now suppose how will the receiver check that this data is correct or not? Now suppose the data has been sent to the receiver perfectly, there is no error into the data. Now the receiver also has this polynomial, so the receiver will divide this data from this polynomial. It means again that binary division will take place. Okay, so if we do 1 1 0 0 1, we can do it fast enough. 0 1 1 0 0, and we have append a 0 here, so it will be 1 1 0 0 1. It will 0 0 0 0 1. 1 1 0 0 1, it will be 0 0 0 0 and 0. Okay, so now our remainder is 0. It means the data has been sent perfectly. And now suppose there will be any change in the data in the middle, like suppose this one becomes 0 or this 0 becomes 1, then this remainder can never be 0. So this receiver will come to know that there is an error into the data. So by in this method, by using the cyclic redundancy check, we can find that if there is a error or not. And as I said, that it is the most practical method we can use for error detection, and it is used in the real life to find the error into the data. Thank you.